JSC manufacturing Polymer-Apparat. Our scientific production association Polymer-Apparat was founded in 2003. The main manufactured products are metal-oxide sedge arresters with gaps, MOSA, in polymer isolation. Major production facilities of our company Polymer-Apparat are situated in St. Petersburg. Majority of our engineers were involved in the research and production of sedge arresters at the High Voltage Engineering Department of St. Petersburg State Polytechnical University in the early 80s of the past century. Modern sedge arresters are the most effective means of protection against overvoltage. Sedge arrester is a column of highly nonlinear resistances, varistors, enclosed in a sealed housing. Sedge arresters don't contain series-connected spark gaps, which detach their nonlinear resistance from the effects of working voltage, and, in normal operating mode, current flows constantly through varistors of the arrestor. Under operating voltage, current through varistors doesn't exceed fractions of milliampere, but during overvoltage, hundreds and thousands of amperes are reached. Surge arresters let through energy surges into the ground, while the overvoltage in the grid becomes limited to permissible level for the electrical isolation. Our scientific production association Polymer-Apparat uses varistors of German company EPCOS for assembling arresters. Company EPCOS manufactures complete range of power varistors, which allows to produce devices for any voltage class, from 220 volts to 750 kilovolts in single column design. Varistors from EPCOS don't age during complete operation period, even under voltage 20% higher than the recommended value. Face surface of varistors from EPCOS are subjected to grinding. Lateral surface of varistors are vitrified. On each varistor of EPCOS, its primary protective characteristic that is indicated: residual voltage during rating discharge current, which allows the manufacturer of MOSA to indicate the protective characteristics of the entire surge arrestor with maximum accuracy. Availability of operating stock of varistors allows us to offer the customer the same short manufacturing time for any type. Our company, Polymer-Apparat, always have available in stock off-the-shelf 6 to 35 kV arresters and components, which allow to produce and deliver the customer any 6 to 5 kV arrestor within 2 or 3 days. Assembly of sedge arrestor is done according to a residual voltage at rated nominal discharge current that is indicated on each varistor. These values on varistors are checked during entry control of each batch. During the first phase of sedge arrestor manufacturing, the necessary varistors columns are assembled according to specification and passed on to production. Manufacturing of 6 to 10 kV surge arresters. Column of varistors with aluminum flanges at ends are placed in thermoplastic automated machine and housed. Explosion safety valves are mounted along the housing of future arrestor. Workpieces are covered with adhesive composite and heated. Then the workpiece is coated with organic silicon rubber using compression method. Application of rubber directly on the arrestor flange and usage of adhesive composites ensure design hermeticity. Housings of category 2 overvoltage arresters are made of glass nylon composite directly on thermoplastic automated machine. Type, serial number and date of manufacture are indicated on each arrestor. All arresters are subjected to acceptance test, then packed and shipped to the customer. Manufacturing of 35 to 750 kV surge arresters. Our company Polymer-Apparat is the only Russian company that uses LSR, liquid silicon rubber, technology in the production of overvoltage arresters. Liquid electrotechnical silicon is applied directly to the lateral surface of varistors. The current flowing through the MOSA to earth can significantly heat the varistors due to limiting overvoltage. Functionability of sedge arresters, to a large extent, depends on its ability to dissipate heat, i.e. cool down after exposure to surge. Unlike the traditional design of surge arresters, there is no material with poor thermal conductivity between varistors and the ambient environment that ensures fast heat dissipation from the varistors. Load-carrying structure of MOSA is a cage of glass fiber, which ensures high mechanical strength and full explosion safety. Non-explosiveness of arresters is confirmed by tests in the laboratories Kratovna in Czech Republic. Arresters withstand short-circuit current of 65 kA without explosive destruction. Arresters are manufactured using the molding machine manufactured by company 2KM, Germany. The machine consists of press, mixer, hydraulic unit and control computer. Column of varistors in the housing with aluminum flanges at ends are placed in the press mold. Cavity of press mold with the workpiece is vacuumed. Two components of liquid electrotechnical silicon, mixed in equal proportions, are applied directly to the lateral surface of varistors. Process may be controlled manually and in automatic mode. This technology ensures the absence of internal cavities and complete hermeticity of the housing. With the help of molding machine, MOSA 35 and 110 kV, as well as 220 to 750 kV, arrestor modules are manufactured. Then arrestors are marked, packaged with protective screens and insulating bases. Exit controls of arrestors is conducted on the stand of 200 kV. If necessary, surge arrestors of classes 220 to 750 kV can be tested in assembled condition. Arrestors are packaged and delivered to the customer. 330 kV surge arrestors are in one of the largest substations of northwest Russia, Vostochная. More than 200 metal-oxide surge arrestors, without gaps of our production, are installed there. Arrestors are finished with current conductivity sensors, which enable monitoring of device state without disconnecting from the grid. Specifications for all types of arrestors are in accordance with the Open Joint Stock Company Federal Grid Company of Unified Energy System, JSC, FGC, UES. Product has undergone a full range of tests. Upon request from our customers, tests for seismic stability at intensity of 9 points were successfully conducted. Our arrestors are in most important sites of power industry. In recent years, metal-oxide surge arrestors are installed on towers or overhead line wires to protect the isolation of overhead lines from lightning and switching over voltages. The need for their use is dictated by the increasing demands on the quality of transmitted energy, reduction in number of disconnections of overhead lines, and interruption in electricity supply. The main purpose of linear surge arrestors is to protect overhead lines from lightning in those circumstances where the traditional measures are not sufficiently effective or difficult. In Russian Federation, arrestors were used for the first time in 330 kV overhead lines of energy transit Russia-Finland to protect the isolation of overhead lines. Arrestors of company ABB were installed on towers with an abnormally high grounding resistance to protect against reverse closing and prevent the two-circuit disconnections of line. When lightning strikes the lightning protector line or directly the tower with a small resistance to ground, lightning current flows through the tower body down into ground. If the grounding resistance is large, a potential sufficient enough to override the linear isolation may occur in the traverse. Isolation breakdown due to lightning surges are likely to be converted into power arc, causing disconnection of overhead line. Surge arrestors are installed in parallel to the linear isolation. Lightning current through surge arrestors spreads into the line phases and flows through the tower body. In this case, isolation closure and disconnection of overhead line doesn't occur. Surge arrestors are also used on overhead lines in glaze ice areas where suspension of lightning protection lines is not practical. This principle of protection was successfully applied to a new generation of overhead lines for Olympic facilities in Sochi. Metal oxide surge arrestors with gaps of our company Polymer-Apparat were installed only in the upper phases and replaced lightning protector line. During the operational process, damage to linear arrestors is unlikely but possible. In order to prevent the steady short circuit, a special device separator is designed, which disconnects looped circuit that connects the device with tower or phase line, depending on the version of MOSA suspension. After, separator's response line becomes alive by automatic reclosure. Protective devices were developed in the Siberian Scientific Research Energy Institute, which were specifically designed for installation on overhead transmission lines, surge arresters with external spark gap. At the final stage, in 2007, the development was carried out, involving potential manufacturers of the protective devices, our company, Polymer-Apparat. As the result, metal-oxide surge arresters for overhead line were developed, which were assembled basing on zinc oxide varistors, series RVL. Under effects of lightning surges, which threaten line isolation, air gap of arrestor is breached, connecting waking resistor to the wire. Under effects of voltage with industrial frequency, current through the waking resistor is limited to the values at which the existence of the arc in the spark gap becomes impossible. Arrestor of type RVL on 110 kV overhead lines, Aleshinskaya и Pimskova oil field. This is one of the most important oil-producing company in Siberia, on the intermediate tower, on the anchor tower. The operating principle of the arrestor is implemented also in 6 to 10 kV overhead lines. Since 2006, devices of type UZPN for protecting 6 to 10 kV overhead line from surges are being successfully used on overhead lines with both isolated and bare wires. Our company produces surge arresters with insulating bracket and the separator for the voltage class 6 to 10 kV. Such connection of protective devices allows organizing uninterrupted power supply to consumers. In case of unregulated influences, direct lightning strike, etc., and damage surge arrestor, separator breaks earth circuit and thereby eliminating steady short circuit. Device type LVA is designed to protect isolation of 0.4 kV distribution grid from lightning surges. The devices are intended for protecting linear isolation as well as other equipment of 0.4 kV grid from induced surges. In 2008, the production of high-voltage fuses of type PKT and PKN production lines are situated in Yuzhno-Uralsk in the Ural region. Our arrestors are installed in all regions of Russia, Baltic countries, and in some of the Commonwealth of Independent States like Ukraine, Kazakhstan, Belarus. Our surge arrestors have been installed to ensure uninterrupted power supply to Olympic facilities in Sochi. Also gained experience in supplying our products to Asia and Africa. The best confirmation of quality of our products, reliable operation over the entire period of service.